In this final unit of the year, we're looking at matrices. And before we start doing some real deep, heavy thinking with them, we are reviewing matrices. And so we're talking about the vocabulary of them, the dimensions, the elements, the rows, the columns. And in example one, we're just in part A, the dimensions of A. Remember, that's rows by columns. The dimensions of matrix A are 2 rows of 3 columns. And what you need to realize when you see the value of A sub and then that number, your first instinct is probably to look at it as A sub 13, but it's not. It's A sub 1, 3. So it's the term in row 1, column 3, which is negative 18. And a little bit more vocabulary on the screen, and you have it in your notes. And of course, adding and subtracting matrices is very intuitive. You're just adding the elements in the corresponding positions. So in the next example, part A, I'm adding matrix A to matrix B. So for part A, the sum of those two is 20, and then negative 4, 1, and negative 9. In part B, I'm asked to subtract matrix B minus matrix C. But since they do not have the same dimensions, it does not exist. You can only add or subtract matrices that have the same dimensions. In example 3, we're doing what is called scalar multiplication. So you're taking a constant, a number, and multiplying it by the matrix. So what you're doing is taking each term, each element, in the matrix and multiplying it by the scalar. So for part A, my new matrix This is very intuitive stuff. Part B, same exact idea. I have negative 8 and positive 36, negative 28, negative 12, 44, and negative 16. The properties of matrices, if I'm adding matrix A plus matrix B, that's the same thing as matrix B plus matrix A. Associative property of addition, same thing. I can put the scalar out in front, just like I can put it in the back, and it would still be distributing. So in example 4, I'm finding this value, so that would be equivalent to 4 times matrix P plus 4 times matrix Q, which would boil down to, well, 4 times P is 12, 32, negative 8, negative 20, 20, negative 16, and I'm adding to that 4 times Q, which is negative 16, 20, 28, and 12, negative 40, negative 24. So my final sum is negative 4, 52, 20, negative 8, negative 20, and negative 40. Finally, I'm solving a matrix equation, so I know that 4 times the matrix X minus B will equal A. So let's get matrix X by itself. 4X is going to equal matrix A plus matrix B. And how would I get rid of that 4? I would multiply both sides by 1/4. So matrix X is equivalent to matrices A plus B multiplied by a scalar of 1/4. All right, well, let's figure out what A plus B is. That's negative 4, 8, 12, 16, 0, and negative 8. And since X is 1/4 of this, I'm just going to take each term and divide it by 4. That means matrix X is negative 1, 2, 3. And then in the next row, 4, 0, and negative 2. In algebra, you solved systems of equations. And what we're doing in this chapter is looking at how we can use matrices to solve those systems of equations. Remember that in solving systems, what you aimed for was getting the value of one variable, and then you substituted it in for one of the equations with 2 variables, and then you took those values and plugged them into one of your original equations in 3 variables. And so this 3-2-1 kind of lineup is what we call row echelon form, and what we want in row echelon form is for the coefficient of each leading term in that 3-variable equation, 2-variable equation, 1-variable equation, is the coefficient would be 1. And you'll see what I mean when I work the problems out. So operations that produce equivalent systems. If I take one equation and add it to another, if I add a multiple of one equation to another, if I multiply an equation by a non-zero value, if I switch to equation, then I end up with an equivalent system. So in example 1, it's asking us to write the system of equations in triangular form using Gaussian elimination. So what we're aiming for is, as I mentioned earlier, the first equation to be in 3 variables with a leading coefficient of 1, the second equation to be in 2 variables with a leading coefficient of 1, and then the last equation to be just z equals a number. So how will I achieve that? I'm going to switch equations B and C as my first step. And I'm going to call these equations by letters, and I'm going to be very specific about what I'm doing in each step, so that we don't lose track of what we did, and if we end up at the end with something that doesn't make sense, then we can retrace our steps and see where it went wrong. And so showing your work is huge here. All right, so my new system is x plus 2y minus 3z equals negative 28. Negative x plus y minus z equals negative 5. And 3x minus y plus 2z equals 3. In my next step, since adding equation A to equation B would result in equation B not having any y's left, I'm going to do that. So I'm keeping equation A the same, so x plus 2y minus 3z equals negative 28. And then I'm adding A plus B in this line to get 3y minus 4z equals negative 33. And I'm going to leave the third equation alone. At this point, I'm going to multiply the first equation by -3 and add it to the third equation. Again, I want to winnow these equations down from 3 variables down to 1 variable. So I just said I'm going to leave equation A alone. I'm going to leave equation B alone. And my third equation is going to be -3a plus c. And so that will result in the x's canceling out. -3 times 2 is -6, plus a -1 is -7y. -3 times -3 is 9, plus 2 is 11z equals, and I gotta pull out my calculator for this one, -3 times -28 is gonna be positive 84, plus 3 is 87. Okay, so I've winnowed the last two equations down to 2 variables. Now I need to do something so that that second equation has a leading coefficient of 1. And this is where some real number sense comes into play. I look at that 3, I look at that -6, and I realize if I multiply that second equation by 2 and add it to the first equation, add it to the third equation, I end up with -y. So first equation, I'm leaving alone. In my second equation, I'm going to take c plus 2 times b. And so that'll give me -y plus 3z equals, so I've got -66 plus 87 is 21. And I'm going to leave the third equation alone. And so we're getting closer now. And what I'm going to do 2 things in the next step, just to save you a little bit of paper, I hope. So I'm going to leave the first equation alone. My first equation already looks the way I want it to. X plus 2y minus 3z equals -28. In my second equation, I'm just going to change the sign. In my third equation, I'm going to multiply by -7, the second equation, and add the third equation. So this will be -7b plus c. Okay, so that means I've got y minus 3z equals -21. And my y's are going to cancel out. I'll have -21z plus 10z, 11z, giving me -10z. Again, I need my calculator. -7 times 21 plus 87 is -60. And now we're almost there. First equation and second equation are good. I'm going to take c and divide it by -10. And then that'll give me that z is 6. And so now I just need to substitute that z in and solve. So when I substitute z into the second equation, I get y minus 18 equals -21. So that means that y has to equal -3. And finally, x plus 2 times -3 minus 3 times 6 is is going to equal negative 28. Okay, well, x minus 6 minus 18 equals 28. So that means x is negative 4. So my solution finally is negative 4, comma, negative 3, comma, 6. And we do the same for part B. So first thing I'm going to do is rearrange these so that this equation is first. Next, I'm going to multiply the first equation by negative 6 and add it to the third equation. So first equation I'm going to leave alone. Second equation I'm going to leave alone. And my third equation is going to be a result of taking negative 6 times a and adding c to it. That will cause my x's to cancel out. And then negative 6 times 2y, that's negative 12. Y. Positive 24z plus another 4z is 28z. And 6 times 18, actually negative 6 times 18, is negative 108, plus 0 is negative 108. Now I'm going to multiply the first equation by 3 and add it to the second equation. So I'm still leaving the first equation alone. Negative x plus 2y minus 4z equals 18. I'm doing 3 times a plus b so that my x's will cancel out. And then 3 times 2 is 6. Plus 5 is 11y. 3 times negative 4 is negative 12. Plus 8z is minus 4z equals 3 times 18 is 54. And 54 minus 20 is 34. And I'm going to leave the third equation alone. I'm going to do a couple of things in my next step, so I hope you don't mind. I'm going to change the signs of equation 1. So I'm going to say I'm doing negative a. That will give me x minus 2y plus 4z equals negative 18. So I got my first equation looking the way I want it. In order to get my second equation closer to looking the way I want it, I'm going to take the opposite of equation C plus B. Okay, so if I add those two equations together, I get negative y. But since I'm taking the opposite of that, I get just y. Okay, for my z's, when I add those two together, I get 24z. I'm going to change the sign so that it's minus 24z. And then I'm going to add the negative 108 to positive 34. That is negative 74. And I'm going to change the sign of it so that it's positive 74. And I'll leave my last equation alone. Negative 12y plus 28z equals negative 108. And so now the last thing I need to do is get rid of the y's in my third equation. And so I'm going to leave the first equation alone. Leave the second equation alone. But I'm going to rewrite the third equation as 12 times the second plus the third. And so that'll result in my y's canceling out. When I take 12 times negative 24 and I add 28 to it, I get negative 260z equal to, okay, I'm taking that 74 now and multiplying it by 12, so 74 times 12 plus that negative 108, and I get 780. And before you start panicking and saying, oh my gosh, these numbers are crazy, I must have done something wrong, look at that 260 and 780. I can take that whole equation, that equation C, and divide it by negative 260, and lo and behold, z will equal negative 3. So that's what I'm going to do in my next step, is take that third equation so first equation stays the same. Second equation stays the same. Third equation is C divided by negative 260. And that just gives me z equal to negative 3. And once I know that, I can substitute it in to figure out what y is. So I know that y minus 24 times negative 3 has to equal 74. All right, well, 24 times 3 is 72, and that's going to be a positive 72, so y must be 2. And then x minus 2 times y, which is 4, plus 4 times z. I know z is negative 3, so 4 times negative 3 is negative 12, is going to equal negative 18. So negative 4 and negative 12 is negative 16. That means x must be negative 2. So my solution then is negative 2, comma, 2, comma, negative 3. So we can use augmented matrices to make this process a little bit less painless. And so in example 2, we are just writing the augmented matrix, not solving it. So in an augmented matrix, we have the coefficients from the left-hand side and then the constant from the right-hand side, and they're separated by a bar. So here's what it would look like. In part A, I would have 4, negative 5. Notice that there's no y term, where y terms do exist in this system, so I need to put a 0 there as a placeholder for it. And then 7, and then I have the line of separation between coefficients and constants, negative 11. In my next line, I have negative 1, 8, 3, 0, and 6. And in my last line, 15, negative 2, 0, 10, and 9. And that is my augmented matrix for part A. Part B, similar idea. I have the same variables, W, X, Y, and Z. I'm going to try to write smaller. Negative 3, 7, 1, 0, bar, 21. 4, negative 12, oops. See, happens to the best of us. 0, negative 12, 8, and 5. In the next row, I have 16, no X term, negative 14, 1, and negative 2. And in my last row, 1, 1, 2, 0, and 7. So that's what an augmented matrix looks like.